This video is for familiarization only and is designed to assist in pre-emergency planning for incidents involving our nation's railroads. The information presented in this video can assist your agency in developing safe and effective protocols and incident response procedures. This video and the information contained herein is not intended to take the place of actual training, replace basic safety rules, departmental guidelines, or established regional response protocols.
Train derailment at the Norwalk Metrolink station.
And our greatest need, probably right now, is going to be that hazmat mitigation.
Derailed and struck a freight train carrying hazardous materials. I will dispatch units right now.
How many victims you have initially?
11.
11. Were you able to locate the conductor?
The units stand by and do not move until you hear identifier to go into the zone.
Nobody can predict when a train derailment or collision may occur, so any incident action plan must have extrication as a consideration. Review your incident response plan to ensure it includes extrication of railroad employees. Just like any other incident that you are dispatched to, railroad incidents such as derailments and collisions can create unique challenges for responders. A good scene size-up will assist the incident commander in determining the magnitude of the incident. Remember that railroad incidents can include several miles of area and that product carried on freight railroads can exceed 10,000 tons. The mitigation of hazards, fire suppression, and extrication of the injured may quickly exceed your local resource capability. It's important to know these fundamental and critical rules whenever you're entering a railroad property. Number one, always notify the proper railroad authorities before you enter railroad property or their right-of-way. Number two, always expect a train on any tracks in any direction at any time. Number three, no units or personnel are to enter the track until the incident commander has confirmed and verified that all trains are stopped. Number four, always secure locomotives and rail cars from movement before working on or near the equipment. Number five, do not operate any valves, relief devices, or any kind of mechanical devices on cars or locomotives, especially tank cars, without the assistance of railroad employees. Number six, always use the safety handles, platforms, and ladders provided whenever possible. Always maintain 3 points of contact. Number seven, use care when working around twisted rails and other metal. Twisted rails and metals tend to return to their original shape when the pressure or tension is released. Scene safety is our number one priority. We can't do anything to help out or mitigate the problem if we're not safe. So we definitely need to contact the railroad and get tracks shut down, especially if there are multiple lines going through the area. We must consider any railroad emergency to be a potential hazmat situation until we can prove otherwise. There are several ways to determine a potential hazmat situation. Talking to the operating railroad, talking to the engineer or conductor if available, looking at the train consist to see what the train is carrying, recognizing placards on the cars, or just seeing if we can observe any spills or leakage. You generally won't know what type of freight the train is hauling. It may be loaded with bulk material with commodities like coal, grain, or fertilizer. It's likely to also carry liquid bulk such as liquefied petroleum gas or chemicals like ammonia or chlorine.
In that initial size up, one of the things they have to deal with is rail traffic. Just because you've got one train doesn't mean you'll have 6 or 7 more coming through in the period of time that we may be dealing with this incident. So if we're having to get a hold to shut down traffic here, is it a spur line, is it a main line? What kind of rail traffic will be coming soon? If we don't get a hold of our dispatchers early to find out what may be heading our way, which could generate a whole nother issue or a whole nother incident. So that contact, getting a hold of the rail dispatchers to find out exactly, okay, can we stop the traffic? What do we got coming? It's kind of like weather. You know, one of our incidents, whenever we're dealing with kind of hazardous materials, we always got to worry about weather. What's coming our way? How soon is it coming our way? These kind of issues in rails are exactly the same thing. When's the train coming? Which way is it coming? And what time do we expect it to get here?
A train derailment is going to be unique in its own situation depending on the area. If you are near a grade crossing, be aware that the dispatching railroad IOS required to provide ENS or emergency notification system signs at each highway, rail, or pathway crossing. Each of these ENS signs shall display the necessary information for the dispatching railroad to receive reports of unsafe conditions at the crossing, and have white text set on a blue background with a white border, except that the U.S. DOT National Crossing Inventory Number may be black text set on a white rectangular background at a minimum. Each sign shall include the following information: A, the telephone number established to receive reports; B, an explanation of the purpose of the sign; and C, the U.S. DOT National Crossing Inventory Number assigned to that crossing. We may encounter these railroad emergencies out in areas where they're not going to be easily accessible. It could be out in a rural area, maybe a bridge or on a hill. Maybe there will be no roads leading to it, or it's on a hillside, or it's cutting through a mountain. Any place we may need specialized vehicles to even assess the scene, which is another good reason for us to work with the railroads, because they have the specialized vehicles that can run on the tracks. So we may have to put our equipment on these specialized vehicles to even gain access to the locomotive or primary scene.
Depending upon the initial call, if it's passenger or cargo, typically we're going to be dealing with unstable rail cars or locomotives. If they're off the rail, the problem is, you know, they're heavy, they're big. So our first thing is always rescue. So where may they be? Where could these people be? Are they, if we're dealing with a passenger car, is it 6 different ways, or where is the locomotive? It could be under 7, 8, 10 different hazardous materials cars, or some coal cars in our area, what we were dealing with, things along that line. So they've first got to find where their incident is, and it's going to take them a while to get that. And then to relay the information back, I mean, you're looking at logistical issues. What we practiced is how to get in and get out, but is that going to be an issue? Are we going to need specific rope equipment? Are we going to need specific extrication equipment? Can we even access the scene? You know, you deal with rail incidents, you're dealing with something from, if you're in the rural area, it's just difficult just to get to where the incident may be, not having anything to say about what may be when we get there. When you're in the urban area, now you're dealing with the same kind of an issue. We're a little bit more, we can get better access to the incident. However, now we're dealing with climbing over and around and under and trying to figure out where exactly these people or the locomotive and that stuff may be.
If we have a railroad incident, collision, or derailment in a public area, not only do we have to shut down other railways and rail lines, but also local automotive traffic. And then we have to see if there's any kind of public or utility hazards involved. If they took out a power pole, do we have any leakage in the sewage systems and the water systems? Traffic control, obviously, law enforcement for scene control also. When you have a situation like this, it tends to gather attention and people want to come see what's going on. So we have to be able to control the crowd and keep them away from the incident. Until it is confirmed that all tracks and traffic on the railway is shut down and stopped, make sure that you don't park any kind of vehicles or equipment on the tracks or in the right-of-way. The locomotive is about 70 foot long, 16 foot high, and 10 foot wide, and can weigh in excess of 400,000 pounds. The locomotive is equipped with a diesel engine that actually drives the electrical generator on one end and an air compressor on the other. Wheel trucks, or the wheel sets, can weigh 37,000 pounds. The locomotive essentially just sits on the wheel set and really aren't bolted or locked together. The locomotive generally contains over 5,000 gallons of diesel fuel in a single saddle-type tank, 430 gallons of lube oil, and 40 cubic feet of sand in the front and the rear, and also has about 380 gallons of cooling water. The power is provided by multiple 32-volt battery banks. The generators can produce up to 600 volts of DC or 23,000 volts of AC power to the motors that drive the locomotive, and they may use up to 2,000 amps each. Another hazard to be aware of on a locomotive is the air compressor and the reservoir tank. The main reservoir typically is charged to about 140 psi. Even though the glass used in a locomotive is considerably heavier and thicker than used in a car, we can still breach these windows and windshields in the same manner as we do a vehicle. The majority of the tools that we're going to use to do a locomotive extrication is pretty much going to be narrowed down to simple tools such as Halligans, Huck's bars, pickhead axes, sledgehammers, and a K12 saw. Spreaders and cutters that we have on the trucks to do vehicle extrication don't have a whole lot of use in locomotives. A pickhead axe can typically bust through a windshield of a locomotive. We can use the pickhead axe to chop through a windshield to remove it to extricate a conductor and engineer out of the cab. We also have the possibility of removing the gasket from around the windshield and removing it in one piece. However, we have found that chopping the windshield is much quicker and more efficient than trying to remove the gasket. So locomotives usually have two armored steel doors, one in the nose and one in the cab rear that provide passage through the cab. Just like any kind of other forcible entry situation that we may encounter, we're always going to want to try to open the door before we start breaking stuff. Try before you pry. It may be as simple as taking out the window in the rear door to reach through and unlock the door, seeing how the majority of the time, if the cab is occupied, the doors are going to be locked from the inside. Because of the unique situations that may occur in a collision, sometimes the door may be jammed in to where you cannot open it even if it is unlocked. The good thing is on the locomotives, most of the doors swing to the outside. With that being said, you know that the hinges are going to be exposed to the outside. You may be able to remove these hinges by using an impact driver and removing the bolts, or taking a K12 and cutting the hinges altogether. Just be very careful because these doors are very heavy. Sometimes the collision may provide a purchase point where we can get a tool in there to open the door. There's going to be a lot of differences between a locomotive extrication situation and a regular vehicle. The steel that's used on a locomotive is going to be much heavier and much thicker than what's used on a typical car. Your access is going to be challenging because of the narrow passageways and the stairs. So you have to make sure that you always have 3 points of contact and be careful what you're doing, because 9 times out of 10, any kind of extrication techniques that we're going to use on a locomotive is going to be in an elevated position. You're not going to be on the ground.
Immediately you guys start thinking, depending upon the cargo, if you're dealing with a passenger train, you're already got a mass casualty incident before you've even arrived. You know that's what you're going to be dealing with. When vehicles tend to crash or wreck, or we have a motor vehicle accident, you'll have something that maybe one vehicle on its side into each other. We have to cut some doors and things like that. But when you're dealing with rail, you've got a lot of inertia that leads into the incident. So typically it is a lot of cars or locomotives or whatever may be involved, stacked, piled, and you're dealing with a much more larger scale incident. A lot of times when you're dealing with anything that's rail, what we hear is not where it happened. If you get a call that's at the 2 mile marker, it's going to be at the 3 or 4 mile marker. So immediately we're thinking our incident is usually larger than, not like any other vehicle. If you have a motor vehicle accident, you'll have something that'll be in an intersection or related to a building. But when you start dealing with rails, it's typically a larger incident just in its scope. By that I mean, you're dealing with a large community. You got the public that we're dealing with. We've got people that are trapped in these trains, could be trapped in the cars. Also, depending upon what the cargo is. If we've got a hazardous material, that incident has grown in scope immediately. What do we do? How are we going to be able to contain this? It's a whole new level of what we're going to have to deal with in its impact in both the city and with the incident as we're dealing with it, resources wise. Are we going to have enough? I'm already going to 2nd, 3rd, and 4th alarms. Are we calling for other help? Do we need to get some industry involved depending upon what we're doing with it, hazardous materials and stuff?
Well, the number one role for the incident commander is to control the scene, keeping his personnel safe and trying to figure out what resources he needs to mitigate the problem efficiently and as quickly as possible. On any incident, you have to have a chain of command. You have to have one person that's in charge, and he'll be able to delegate responsibilities down from that as to what's needed as far as safety or logistics or tactics or actually doing the job of getting in there and cutting out the engineer or the conductor out of the train. There's also going to be multiple other resources involved, like law enforcement, maybe Department of Transportation, specialized hazmat companies possibly.
Incident command is definitely an important aspect to any incident. When you're dealing with something like this, a lot of times when you're dealing with some rescues or things, it's more what's in front of you. You really don't have anything pushing from behind. But when you're dealing with, large-scale incidents with either mass casualties or hazardous materials or other agencies, the incident command has to be that liaison between what's going on. We're going to arrive on scene firstly. We're usually going to set up some sort of a unified command, which is going to have all the interested parties involved in the command process at some point in this. And what we have to be able to do is I have to be able to get the information from my first arriving officers back to me so that I can get it back to the responsible parties so that we can start getting an information flow of what may be on this that we don't know, how many people may be in here that we haven't seen. And then when they come down, they can kind of, we coalesce at the command post, and now all of a sudden our incident is, the information is flowing both up and back from the agencies, from all the responders, down to the guy that's on the end of the tool that's working at the locomotive. Command has to be there to provide both levels of information and to, when we decide tactics or what we're going to do, we have to develop plan A, and typically that takes a group of people back off the incident to come up with plan A and plan B.
If we need to extricate the engineer and or conductor out of the cab, we're going to go ahead and assume that they're injured. Therefore, we're going to need special products to remove the injured personnel from the cab, whether it be a Skedco or Stokes basket and backboard. Obviously, we're going to access the cab as easily as possible so we don't create any more additional work on us. When we get in there, then we can see what would be the easiest way to remove the personnel from the cab. Once you get into the cab of a locomotive, you're going to find that the area is very restricted. Some of the things that you're going to find will be the engineer's control stand, the engineer's seat, the auxiliary control panel. That's usually back behind the engineer's seat. On that control panel, there's a big red switch clearly marked emergency shutdown or fuel shutdown. If you need to shut this down, push in that big red knob and hold it for at least 5 seconds. In addition to the emergency shutoff switch behind the engineer on the electrical compartment, there's also one on either side just above the fuel tanks. Remember, if you have to do this, first you must set the handbrake and ensure that the wheels are chalked.
Remember that the locomotive may not always be at the front of the train. It could be in the middle or at the end. Once inside, on the main electrical panel, there is also a knife switch and primary fuse that will kill most of the electrical power to the locomotive. There is still a chance that the electrical panel behind the cab will remain energized.
The air routing areas, the radio and e-brake consoles, and also this is a good place to look around and try to find the consist of the train. This will give an itemized list as to what kind of cargo the locomotive is hauling. In addition to these items, there will also be a sanitary compartment or toilet there in the cab area. You may have the possibility of human waste spilling from the collision. This is also another good location to try to find crew members. Even though we may access the cab through a door, we still may be required to create another opening to get someone out. The doorways in a locomotive are extremely narrow, and trying to get someone out on a backboard or a sked may prove very difficult. Therefore, we may have to utilize the windshields or even the side windows and open those up to be able to remove a patient from inside.
If all else fails, we can go through the roof. The roof of the locomotive is typically the softest part of the locomotive and should be easily cut with a K-12. Use caution if cutting a hole in the roof. A lot of the cabs may have exterior mounted equipment like antennas, air conditioners, horns, and all sorts of wires. These may present some challenges trying to find a suitable area for entry. There is also a chance that 110 volt of power could be running through lines in the roof, so you may need to shut off the power to the train before cutting the roof. However, the roof does present a potential entry point to the cab.
If you have to take out a windshield, like I said before, the front windshields are much heavier and more durable and thicker than those in a car. They're also a little bit more thicker than what's encountered on the doors and the side windows. The side glass can be removed, again, by chopping it out or cutting it out, or possibly even with an impact wrench and removing the entire frame as one. If you are called to a collision or derailment and find that the locomotive is on its side, we have to take into consideration, again, the way the doors may swing open. It also may be easier to go through the roof at this point, seeing how it'll be ground level and we won't be in an elevated area to work with the tools. You may encounter a lot of debris on a collision. You may be required to use a K12 or other tool to remove debris so you can even access the point where you need to gain entry. Normal spreaders and cutters and other extrication equipment, the hydraulic stuff that we usually use on cars, probably isn't going to work very well on locomotive steel.
When you're dealing with things like the rails, pre-planning is essential. If the guys coming off the truck know that they're dealing with a locomotive, they're going to know what access points they're going to have. It's going to give them a pre-plan on what to be able to deal with. We talked about the distance that you may have to go from your fire apparatus to the actual incident. They may have to walk in. So knowing what they're going to be dealing with, they can pre-plan by carrying the correct equipment in. And now we're saving ourselves time from walking all the way in and having to say, okay, well, we need this tool and that tool and this tool. If they get those tools off the truck, take them in with them, they're saving themselves time to get to these people.
If you have railway activity in your response area, make sure that your department has some sort of incident action plan or SOPs to ensure that you have the right resources, equipment, and training to respond to such a call.
How's that? You good?